All right, welcome. I can see a few people in the fresh NGINX t-shirts. Looks like you got them in our booth yesterday. That's really nice. So today on this talk, we'll be discussing a few things about running our applications and about our new projects, about the things that we recently developed and built for you. But first, probably you know NGINX really well. I'll just give a few updates on where we are right now and how our organization is developing. It's a well-known project that's been out there for more than 10 years now, and currently it's serving well over half of the internet traffic by various estimations. We're currently over 200 employees in various locations. We opened offices in Singapore, in Sydney. We have an office in Cork here in Europe, in Moscow, and a very large office in San Francisco with a bunch of remote employees everywhere. And as the different kinds of software, we're not only making the well-known web server, we're also creating things for running your applications, creating your CDNs, API gateways, and various different things. So a bit about myself. My name is Nick Shadrin. I work for the product management team, and I'm based in San Francisco. I've been working with all kinds of web development, starting from running the network cables and up to infrastructure of the large websites for the last 15 years. All right, so done with introductions. Let's see what we're going to talk about today. First, I want to discuss a few bits about current application landscapes and what we have today in modern applications compared to the various applications that we had in the previous decades. We'll talk about the software that we recently built. It's an open source little thing called Unit, and we'll see how it works there, what kind of architecture is there, and why is it so different from the older application servers and older infrastructures that were available there yesterday. I'll show a few technical things on how to start with this software, and we will have a question and answers section. So if you are on your Slido app, you can ask the questions there, and we will try to answer as many of those as time permits. All right. So let's talk about the applications, and first, before going into the actual code of the application, let's take a look at how infrastructure was changing in the recent years. So 15 and 20 years ago, in order for you to have a new server workload, you had to order a server, and a couple of weeks, or if you're lucky, a couple of days later, it arrived. You had to unpack it, install the system, put that in a server rack, do all of that work, and that means it didn't matter much on how quickly you change your software in that regard. It took you a while to have the new servers up. So today, with the proliferation of the containers, VMs, and cloud environments, you can create new server workloads in the matter of seconds. And right now, with all of that kind of changes in the infrastructure, the rest of your software has to be able to change quickly as well. We often ask the questions to everybody, and if you stopped by our booth yesterday, we did ask you the question, what are you using behind NGINX? What is your platform? What are the languages that you are using there? And most of you answer that saying it's not just one language. We do some PHP and bits of JavaScript. We do some Python for one thing and do some Go programming for another thing. And we see that most of our users, they're taking the appropriate language and the appropriate platform for the task in hand. And those tasks can be different, and all of them, they make sense. You choose the platform accordingly. But the thing is, when you are choosing the platform according to those tasks, you also have to figure out the rest of the application stacks. And if you build something new in the platform that you never touched, your operations teams will have to figure out how that particular stack would have to work correctly? What is the best way of running and launching that application? All right, little bits about microservices. You heard about that trend in the last couple of years a lot. And creating those microservices environments, it makes sense for many. There are many benefits to that. I would say probably it's not for everybody. Sometimes a larger application as a huge monolith, if you say, it might be a better choice for some of the tasks. But for many tasks, having the features and the ability of scaling out some of your services, of taking functionality outside of the larger application, it makes sense. It makes things easier. Sometimes it makes your engineering and your deployment pipeline faster. But let's not forget that when you are taking the parts of your application outside of the monolith, you need to take care about connectivity between those services. We know a lot about connectivity between various HTTP services, but the thing is, the performance of that communication and the architectural approach, that can be different depending on the case and depending on how you're actually connecting those things together. Now that we took our applications apart, now that we are using different areas and different kinds of deployments, we see that the security layer and the security functionality has also changed quite a bit. When everything is running in the public networks or in the cloud networks, you cannot just put a firewall at the ingress and say that everything is secure, or just encrypt something and say that it's all done. No, the levels of security and the distributed security needs to be happening on all of those layers. And many of the infrastructure providers themselves, they say that you shouldn't trust any connectivity just by design. You should treat any network connection as something that can be broken or somewhere that someone else can tap into that. So you need to think about encryption between the services. You need to think about audit and other things around that security layers. Also, when you are running the multiple applications with the multiple types of software, you need to think about how that security works from within the application and throughout. Doing that for the multitude of apps, it just exponentially creates more work for the security team. You probably have heard from your bosses or from your operations teams, like, we cannot install this app, we don't trust it, or we cannot install this thing before we figure out what and exactly how it works. And those are good questions. And in addition to that, when we are looking at the request flow through our microservices worlds, and through the various distributed applications, when we have more connectivity, when we have more connections, securing each one of those actually brings performance down a bit. So those are the issues that we recognized from you, from our users. And what we started to build is the server called NGINX Unit. And Unit is the software that's built from scratch. We didn't take the NGINX code as the basis for Unit. We took the initial understanding of how asynchronous communication works, and we built something completely new and from scratch. So don't think about Unit as an extension to NGINX or as something that works as a module to this application or as an application module to NGINX. No, Unit is a separate development. However, it is built by the same team. So all of that development culture and all of that lightweight style of creating the most efficient software is what we used in the development of Unit. It's built in C, it's focused on performance, and it is fully open source. You can take the code from GitHub, and you can take the packages, you can contribute to that, you can communicate with us. It's the open development. We're very thankful for all of your contributions to Unit. In the very beginning of all of our descriptions of what it is, we always say that unit is dynamic. So what does that mean? Many people, they say, OK, it means it's API controlled, so you can send API requests and it will make changes of some sort. It's not exactly what dynamic means in our understanding. The dynamic server is something that doesn't perform the reload process. It's something that doesn't start additional workloads when your change can be implemented directly in memory. Let me give you a few examples. Let's say you want to change a port number of your server. If you want to do that, it doesn't mean that you need to reload all of your application workers. You can change the port separately from your application. If you are changing things around your keep alive connectivity, about the number of requests that are available in the connection, or any kind of internal settings, it doesn't mean that you have to start a new kind of server or new kind of application. The change can be performed in memory. And that is different from understanding of what is an API-controlled server. When we talk about APIs, those are interfaces to perform that request. How the request will be processed by the server is a different question. So what I'm saying is dynamic and API-controlled, those are two completely separate features in a sense. And the main one for unit is that it is dynamic. You can make changes as frequently as you like, meaning if your infrastructure changes several times a minute, that's totally fine. Some users actually they come to our website, they search for the word reload, and they cannot find it. There is no command for reload. We started building something that's essentially multilingual. As I was saying, unit is designed for running your application code. You give it a code in the language that we support, and you can control how that application is launched, what kind of workers, what kind of user credentials and other parameters you can create there. Another thing is, we noticed that it's not just the different languages that can bring some problems to the larger environments. It's also the versions of the language. We have you ever upgraded your Python installation from 2.7 to 3? Do you usually see the same application for Python 2 and Python 3? Usually not. They are quite different. Same goes with PHP 5 and PHP 7. The versions of the language, they sometimes matter just as much, and they are sometimes as different as different languages would be. We built the functionality for you to run your apps side by side on the same server with various versions of the language. Doing that, it allows you to test things easily. It gives you the ability of figuring out how your application would work in that newer environment. And if it does work correctly, you can put more traffic through it. You can send more data through that application and basically make your update and upgrades between the application languages smooth and easy. In addition to that, all of our application configurations, they are built in the same way. When you had multiple types of app servers, you were basically creating different styles of configuration files. And having those different styles of configs, it meant you had to learn all of them. You had to create the deployment pipelines per app or per type of the application. Here, we are basically unifying all that and giving you the consistency of that operation. Now let's talk more about security of unit. We do launch application processes through different user credentials. And let me say that the Unix systems, the Linux systems, they have lots of fundamental functionality that allows you to secure your applications directly. So use it. Use those different users for your applications correctly. Give your applications different file quotas. Take them into the different directories with the different access levels and so on. That functionality, it works really well, and it's known for decades. In addition to that, we will be working on supporting C groups directly into units, so you would have more resource control over the applications. Now, since we are launching the apps in separate processes, the failures of an application, if something breaks, it doesn't bring the server down. The applications can be easily restarted or relaunched if that is needed. And also, you will be able to see how that application is working directly through Unit. Let me walk you through the things around our architecture of the software. The main process of Unit is just creates a number of various processes as the controller and router process initially. The controller process is usually launched by the controller process is usually listening on an API socket and accepts requests with the configuration updates. You can send JSON data directly into that controller process, and once that configuration lands there, the controller and the main process will communicate with the router. The router is the process that accepts various client HTTP connections. When you are creating the configuration with different listener ports over different IP addresses and so on, you basically instruct the router process to open those ports and start accepting HTTP connections. The main process also creates the application processes. Those application processes are created with the use of the existing interpreters for the interpreted languages. For example, for the PHP, Python, and similar languages, you have to have that software and their embedding library installed and configured correctly in the system. Unit doesn't bring you the whole entirety of Python, Ruby, and other things. They already exist in the system. You have to install them correctly for them to be used. There is a very interesting thing about how we communicate between the router process and the application process. We're doing that through the thing called shared memory pools. And we are basically opening a number of segments of shared memory between the router and application processes. And we send the data across that shared memory. And we control all of that through the socket pair between the processes. What it gives us is superior performance and very quick operation between the two processes. We have some third-party benchmark tests which show that Unit performs really well in high concurrency situations. When you have too many users visiting your applications, that's when Unit will be more performant compared to some older style application servers. Do we have Go programmers in the room? All right, I see a few. I know that Go programmers, they like to ask the question, why do we need an application server? When we do something in Go, and in languages similar to that, every time we create an application, we are starting to listen on our HTTP ports. We're basically creating the application server there with each instance of our app. Same idea applies to the JavaScript programmers. The JavaScript developers listen on HTTP port using Node.js, and basically that itself is an application server. Now, the operations teams, they ask the question to that, okay, how should we configure that for the production workloads? And how would that style of operation, that style of configuration of the application, how that should work with the rest of the infrastructure, with the rest of the legacy environments sometimes? So what we did with Unit, we created a Go package that you include with your application. And instead of performing listening directly from within your processes, you basically allow Unit to execute that binary, to execute your Go binary. And instead of connecting directly to the Go application through the network, Unit will connect to that using the shared memory pools. That will basically decouple your network stack and the HTTP configuration from the application itself. You will be able to smoothly upgrade, take your applications down, create the new versions, take the new ones, change between them, regardless of what the application is. If it's a Go application, a Python app, a PHP app, they are all working in the same fashion that way. Now I'll walk you through a few things about the API that we created. This is something really simple. We support 3 simple methods. It's get, put, and delete. Get and delete, they are pretty self-explanatory. When you put some data into the API socket, that is instantly applied together with the rest of the configuration. And if there is no need to kill or create the application processes, they won't be killed or created. So changing the binding between your HTTP port and your application, it's as simple as sending just one simple request with a curl, or whatever tool you like for that. By default, Unit launches the API on a Unix socket. We can change that to a network port with a control parameter to the binary. However, please, if you are taking the API outside of that same machine, please secure it with the appropriate tools. Create a firewall, create an authentication for that, put that on a local host port, but please don't put the API outside like some guys did recently and had a huge problem on the internet. So for the API access, security first, and Unix socket is there by default for a reason. All right. Here's a little thing about consistency. Those are 3 full types of different applications, and all of that configuration, with the exception of application-specific parameters, is exactly the same regardless of the type of the app. Now that you added something in your stack based in Python or based in Ruby or Go, you basically just take the same kind of configuration and just add the few things that are specific to the language. Well, obviously, Python app it often needs virtual env parameters, or PHP app, it needs to be working through with a particular script or finding an index of some sort for a specific URL. So those things, they are different by the design of how you build applications. We build those and we extend the application support quite often. There are things about operation of Unit through the Unix sockets. It's really simple to add the different areas of configuration. You can talk to any of the objects just by its URL, and make a change as simple as just changing one number using just one character update or with just a put request. Or you can put the full configuration as a file directly into the Unix socket, directly into the API. When you are creating your config as a full file, and when you are performing any of those updates, you will see that Unit will save the configuration directly on the file system. But don't think of that saved state file as a configuration file. We encourage you to make changes to the config just using the API requests and save those files as backups instead of using the configuration file approach. All right, so now you will probably ask me, what should I do with this kind of software? What are the reasons for that, and how we can use that in the different environments? So a few things there. First, Unit provides you the zero downtime on the changes, which means if your environment requires high uptime, it's really easy to use that. There is also no waste on resource on changes. Some might say that, OK, in order for us to have a zero downtime, we'll just launch new sets of applications, new sets of resources, put the traffic there, and then decommission the older resources. Sometimes it works, but sometimes it's just a waste of resource. So Unit provides you the way of keeping the zero downtime without the waste. And that actually leads to running fewer servers. If you are based in a cloud environments of different kind, maybe the number of servers is not a problem, but sometimes the cost is. Now a few things about automation. Since we are using a bunch of pretty well-known standards for our APIs, all of those control systems and the automation systems can work with that just natively. And the integration with those native tools and native APIs, it's seriously easy. Unit works well in a container, so it is available on Docker. You can just do the Docker run with the Unit or include that in any of your environments. Or sometimes it makes sense to run it on the host itself. When you are creating the new kind of applications, it makes sense to try them out in the environments similar to production or directly within the production, which means that if you are taking that new application code and if you need to test it, it's, once again, very simple. You just put a simple API request there, and it's working. Now, the next question for the upgrades and tests, it's the upgrade and test of your application language and application platform. You might have the same app, but you're upgrading from Python 3.5 to Python 3.6. You need to figure out how that application is working correctly on that various environments. The easiest thing is to run them nearby in the same machine. That's really easy, not touching the rest of the pieces, just adding one call. And in addition to that, what you will get is consistency of the operation. We saw, there is a funny anecdote that we recently found on the network. One large organization, they changed their proxy environment from one software to another in one of the cases. And for some reason, their applications broke. If we would never guess what that was. It turns out that the different proxy server that they used, it was configured exactly the same like the previous proxy server, but it was lowercase in the HTTP headers on the way. The application that they created, they didn't expect that the header would be lowercase. However, RFC does allow you to put any kind of caps or non-caps characters in the HTTP headers. Since the application didn't expect that, it broke. It was easy to fix. But the reason for that is, and the message for that is that you need the consistent operation of your HTTP stack across the various apps that you use in the environment. Using the same software is also simplifies things for you. Next, we will see how Unit can be deployed in the different hardware, VMs, or container environments. We often see the questions on how that would work within a container. Well, I would say same, exactly the same as in any kind of cloud VM or on your own server. Configuration can be done locally from within the app. If you are taking that in the remote way of configuring things, if you are doing that remotely, please don't forget about security on your API communication. All right, a few things on what we are going to create and what we are going to do with Unit in the next months, and what we are going to do next is a lot of things related to security, scalability, and hardening of the software. Initially, Unit was released in September last year as a beta. We created the version 1 in April. So it's available for you with 5 languages right now. And we will be creating more language support. We will add more languages of various kind for you. That will obviously include the Java and Node.js, which we hear as the most sought-after languages right now for these platforms. For Java, we will be adding that using the most popular frameworks first. For Node.js, our research and the work on that has already started. In addition to that, we will add the functionality for you to build your apps as executables, as the binary executables in any language that creates those binaries. In the longer term, we found that Unit will fit really well in the microservices environments and in the distributed application environments. For those, it's very important to create a set of ways for you to communicate appropriately between the services. The communication from the internet to your app, just the ingress communication, is solved really well by NGINX. And doing that level of reverse proxying requires less of the configuration changes and less frequent changes to the config. As far as the backend communication between the services, that's where the quick changes are happening. And that's where the different approach needs to be taken for Unit to be able to communicate directly between the apps. In addition to that, when you are seeing the same set of tools for your applications, it will make sense for you to see the same tracing tools and the same ways of troubleshooting those apps. So that is where we will be adding more functionality in the troubleshooting and tracing features. In addition to that, we will be working on instrumentation and monitoring to give you more visibility to the apps. As far as the monitoring features and instrumentation, we have plenty of that available within NGINX and within the proxy environments. But knowing more how your application operates is what will allow you to go to the next levels of troubleshooting and the next level of visibility of the network. All right, so a few things on where to get Unit and what to do with that. So for Unit, for Unit documentation, you can go to unit.nginx.org. That's where you can find the installation guides and a number of other tools. One of the very interesting articles, please don't overlook that one. Take a moment of seeing how it integrates with NGINX and how to put the functionality together and the between of those two types of services. Next, if you have some questions about Unit, well, the best way to ask the questions is to ask them right now using the app, and we will be answering the questions just pretty much after this slide. So if you see how that works and have more specific questions on its environment, you can ask them using the GitHub issues page. So go to GitHub, how would I say it, like and share and retweet. And if you are not a fan of running the open source software or just need to try something quickly, you can just do docker run nginx/unit. So that one will launch it immediately within your environment. However, for Docker environments, it makes sense to use nginx/unit as the basis for your own containers. For many systems, you just take an app, if it's something that is already created as the established application. Unit is a server, so you will need to put your application there somehow. And for that reason, you take nginx/unit as the basis, and then you create your own containers using from nginx unit and the beginning of your Docker file. In addition to that, we created the mailing lists, and also we have an nginx booth here on the first floor. The coordinates of the booth are 1141, which probably means exactly nothing. You can just find it on the floor. We also have a few T-shirts available there in the booth. So if you are lucky, you can grab one of those easily. All right. So right now, let's see the questions that we have, and I will ask you to add all of those questions in that Slido app, and we will see those on the screen. All right. So what makes NGINX Unit better than Kubernetes for this kind of usage? Well, that's a great question. So container orchestration systems, they provide a lot of functionality on how to manage various images of software and how to scale the images of software of various kind. Kubernetes and similar systems, they allow you to create the versions of the whole systems, that you can create databases, you can run a lot of things. But what they are not doing is managing the particular processes of the apps, and they are not managing the specifics of how the network operation works directly into the app. So you can use both of those together. You can use Unit as your application portion of the stack with more knowledge and more insights of how application runs. But you can still use Kubernetes for the infrastructure level control and infrastructure level orchestration of the thing. So the next question is really interesting. It says, can NGINX Unit replace the standard NGINX? We believe that the use case for Unit as launching and creating the app, it's a bit different from the use case for NGINX as the ingress reverse proxy to the environment. There is a slight overlap in functionality there as the direct HTTP operation, but we don't advise creating large applications within NGINX. It makes sense, NGINX makes sense as the web server and proxy into the application. However, Unit is working really well with the application itself. So once again, those are different layers of the environment. The application running and the ingress proxy, the ingress level of your app. OK, so next two questions are quite interesting. We have questions about Node.js backends and the Java support for Unit. Well, both of those things, they are available. They will be available soon. They are on our roadmap. And thank you for confirming our thoughts that Java and JavaScript are the languages that we need to work with. So that's exactly one of the focus of our engineering team right now. Do you handle apps in Docker containers? OK, so Unit can run inside a Docker container. So Docker container can run Unit as a server inside of a container, and in that sense, yes, it runs exactly properly. Next, if you are only using Docker for the reasons of launching various versions of the app or creating the consistent layer of your environment, in that sense, if that's the only reason for your use of Docker, you might use Unit in place of that. However, Docker gives you the functionality of software distribution, the file management, the version of the application files. And this is where they're really good at. They have the Docker Hub, and you can create your own Docker Hubs. That is a very good set of functionality where Unit is working well together. Now, the question about the configuration file persistence. The question says, without the configuration files, does it mean that there is no persistence of configuration? And no, it doesn't. When you send an update to a Unit using the API, it will save the configuration in a state file. When Unit starts, when it was stopped or the server was rebooted, it will take that state file and it will recreate the configuration from that state file. However, we're not advising you to make changes to that file because it will be rewritten. It will be changed by any API request or by any change request to that API. Now we have a question about ASP.NET support. So that's a really good one. So for the ASP.NET, there are different versions of that. There is the Windows ASP.NET, and there is ASP.NET Core. Unit doesn't work on Windows, so that won't work there. However, for the .NET Core support, it's it's not impossible to create the support for Unit for .NET Core. It would be looking similar to what we did with the Go apps and any kind of other executable. So that, that is considered. However, we don't have it in an active roadmap. A good suggestion is to put that question as a GitHub issue and help us track the popularity of .NET Core. Just send us more information on how you're using that and what kind of application details and support you would need for it. All right, so we have a question about multilingual. Multilingual meaning you still support things like FastCGI, or is there a new way to connect to the workers? Different applications, different application platforms, they have their own embedding interfaces. For example, there is the FastCGI interface for PHP. There is the WSGI for Python. There are other kind of interfaces to the language. We are reusing those interfaces. However, we are connecting to that. You are connecting to the application, not using the fast. You are connecting to the application server, not using the FastCGI protocol. You are connecting to all of them using the standard HTTP protocol. For example, if you are running PHP FPM, it means your outer layer of PHP FPM needs to know what FastCGI is and connect to that application through FastCGI. However, your UWSGI server would need to be available through a different protocol there, which means your outer layer proxy would need to support both of those protocols. With running Unit, you have a consistent HTTP protocol layer regardless of the type of the app. So there is a question about plans to support automatic certificate provisioning. We have ACME support in the Unit roadmap when we will support SSL and TLS authentication. We will add functionality for ACME CA and Let's Encrypt like support for Unit. All right. So next, we have a couple of questions about microservices. Why should I run multiple microservices in a single container instead of one microservice per container? Kubernetes pods make sense. All right, so there are various approaches to the microservices environments, and all I can say there is for one case, it might be making more sense to run multiples in one container. In some cases, it might make sense to take them apart. There might be reasons like communication between the services. There is different scalability between the services. There are reasons as security and security domains and various people managing that. And the last question that I will answer today is the one about TLS and HTTPS routing. For Unit, we have plans to support TLS, to support HTTPS, and we do have plans for also supporting HTTP routing based on URLs and other parameters of the request. In addition to that, we will support static files as a type of our backend. So all of those things, we have many of them planned in our roadmap. And we encourage you to ask more of those questions on the GitHub issues page, or just visit our booth and talk to us more today. So on that note, I would say thank you, and we'll see how Unit will work together with you and with your environments. Thank you.